So you find yourself stranded on an island, you're dying of thirst, there's no water anywhere to be found. As you continue walking through the wooded areas, you come across a structure, you enter the structure, and it turns out you're in luck because it's an abandoned US Navy base. When you enter the building, you find an area where there's a stockpile of emergency drinking water. The only problem is, the drinking water is almost 6 decades old. Is it still safe to drink? Let's find out. Now I'm going to be performing multiple tests on the water inside this can to ensure it's safe enough to drink. You can see the date code on top, December of 1965. And when you shake it, sounds like there's still a vacuum inside that can. So once I open up this can, we're going to take a look at the clarity of the water. I also want to see what the lining of this can has on it. We're going to be performing the test you see right here. And we're also going to be using the 6-in-1 tester that I used in a previous video. So you can see over here, we're going to get a score between 0 and 100. Closest to 100 means excellent water quality. And the test parameters are chemical oxygen demand, total organic carbon, total dissolved solids, ultraviolet absorption value, electrical conductivity, and the 6th one really is not a big deal, probably won't even look at it, is temperature. So let's get started by opening up the can. So let's put the can opener on here. I'm going to squeeze down and let's see if we hear the sound of the vacuum. Yep, there was definitely a vacuum. I heard it going in. Let's open this can up. A little hard from this angle. Okay, the lid is now removed, and it looks like there is a tinned surface on the inside of the whole can. The water, as you can see when you look inside, is crystal clear. Let me dump some of this water out into a glass for testing. When I'm performing the test, if you see anything floating in the water, it's the result of removing the lid. Right along that edge, some of that paint flaked off and fell into the can. When I place my nose right above that opening and take a whiff, there is no unusual odors. Okay, so let's turn the tester on. This was cleaned in distilled water when I put it away. Place it inside the water, and then we're going to press M to measure. All right, TDS is 84, and it says water quality is 66. Let me go over the readings right now. I'm going to read them to you. You can see this is lit up, not green. Green would be good. It's coming up 66 average. Let's go over all the different levels. So let's see. So COD is 4.03. TOC, 5.71. TDS 84, UV 275 is 0.057. Electrical conductivity is 167. Now the reason why we had an average reading of 66 out of 100 is because the COD, chemical oxygen demand, was higher than normal, and total organic carbon. Now the total organic carbon came in at 5.71. Normally you want to see that well under 2. Chemical oxygen demand was at 4. That's not too bad, but the TDS is fine, the UV 275 reading is fine, and the electrical conductivity at 167 is okay. What I'd like to do now is go through each one of the tests in this kit to further evaluate the quality of this water. Let's start with the 6-in-1. We're going to be checking chlorine, hardness, pH, alkalinity, carbonate, and total chlorine. Dip one strip in the water for 2 seconds. Gentle, steady swirling motion. Hold the strip 15 seconds horizontal. Do not shake off excess water. Compare and match the test strip's color results against the color chart. If you wonder where I got this kit, a link has been posted in the video description area. 1 1000, 2 1000. Lift it up and just hold it flat. And now I'm going to do some comparison on this chart here. So free chlorine is 0, hardness is 0, pH is up towards the high end, alkalinity 40, let me write this down, and around 40 for carbonate. We're showing a little bit of chlorine here, not much, but a little bit more than 0. All right, so another look at the chart. Let me write these values down. At the end of this video, we'll take a look at all the values. Next test is going to be sulfate. For this test, you dip it in the water for 5 seconds, gentle, steady swirling motion, remove the strip, shake off the excess, and wait 2 minutes. Now I'm going to wait 2 minutes. Okay, 2 minutes has passed. So it kind of has a salmon color. So it's less than 250. I would say it's around 200 looking at this. Next test is copper. For testing copper, you're going to be using the vial that's included. Take the water sample, fill it to this line. You're going to take the tester right here, and you're going to be dipping it 10 times to the bottom, pull it out, and you're going to compare it to the chart. Let's try it. 1. Immediately compare, and you can see there's no copper in that water. Color did not change. Next test is for iron. We're going to be dipping 1 strip in the water sample for 30 seconds. Gentle, steady swirling motion. Remove the strip, shake off the excess water, and then immediately compare the color to this chart. So let's try it. And there is a little bit of a color change here. It's not much. But if I was to say, it's less than 0.1. I would say like in the middle. So let's say 0.05. So a very low level of iron. Now we're going to be checking for nitrates. For this test, we're going to be dipping 1 strip in the water for 2 seconds. Gentle, steady swirling motion. And then hold the strip horizontal for 60 seconds. Okay, lay it right here for 60 seconds. And then we're going to compare it to the chart. Okay, hold that there. Is it this way? Nope, that's the pinkish on the top. So you can see maybe in the nitrate, maybe in the 20 range. Probably around 20 at the top for nitrate, and the bottom no change for nitrite. Now for this test right here, 5 and 1, it's going to check for lead, iron, copper, nickel, and zinc. Dip 1 strip into the water for 2 seconds, gentle, steady swirling motion, hold strip horizontal 15 seconds, and then match to the chart. So let's do that. 1,000 to 1,000. Let it sit for 15 seconds. Okay. Taking a look right here. Lead is showing down towards 0. Iron, just like before, very low number, around 0. Copper, also before, 0. Nickel, 0. Zinc, down towards 0. Very light color over here. So this is all good here. Okay, so after performing 19 different tests on this water that's almost 60 years old, I don't see anything really alarming with this water. The only thing is the elevated COD and TOC. And I think the reason for the higher than normal COD and TOC is because this can is steel, plated with tin. Tin chloride is used in the plating process, and probably after almost 60 years of having the water in direct contact with the tin, some of it leached into the water, and that's probably why the COD and TOC is higher than normal. Tin is generally non-toxic, so I would have to say if you were dying of thirst and you needed water and you came across these cans, almost 6 decades old, you can definitely drink the water. And guys, that's it. I hope you enjoyed this video. If you did, be sure to rate, thumbs up, and share. Thanks for watching.